Okay, welcome everyone to our session on NumPy in Python. What is NumPy? NumPy is a short form for numerical Python. It is an open source Python library for doing scientific computing. NumPy helps us create one dimension array, two dimensions array, n dimension array. And it is the foundation of the Python scientific stack. So if you see the entire NumPy ecosystem, at the bottom you have NumPy. On top of that, you have many other packages. You've got SkyPy, you've got Pandas, you've got Matplotlib. SkyPy is scientific Python. Pandas is a package by which you create data frames, basically in simple term, tables. And you have got something called Matplotlib. Matplotlib is the Python package for creating charts and graphs. So SkyPy is scientific Python where you do all the statistical stuff. Pandas stands for creating tables, data frames, and Matplotlib for charts and graphs. And on top of that, you have other packages: Scikit Image, Scikit Learn, Numba, BioPython, and so forth. So NumPy is one of the package which is a foundation package in Python. What it helps you create? It helps you create a one dimension array, two dimension array. It helps you create n dimension arrays. Okay. So let's just quickly get started. How do we start using a NumPy package? A standard syntax is a very standard syntax of importing NumPy is import NumPy as NP. Control Enter. Now let's understand access in arrays. Okay. So here in the image shown here, it's like a matrix. You've got two dimensions, and this is basically your rows: row 1, row 2, row 3. The way my mouse is moving: row 1, row 2, row 3. The rows is called as axis 0, and the columns: col 1, col 2, col 3, col 4. The columns is called as axis 1. You can imagine a third dimension which is projecting, probably say, into the laptop screen. That can be a third dimension, basically a cube, which is shown here as a 3D array. So when you see the 3D array, so basically your first row wise is axis 0, then you have another axis which is column wise, and the third dimension which is projecting, probably, as I said, visually you can assume projecting inside the laptop, that becomes your axis 2. Is NumPy restricted to only one dimension, two dimension, and three dimension? No. NumPy can become n dimensions. Okay. Each of the cubes which are shown here in this 3D array itself can have more dimensions inside, but most of the time the data that we work on is actually a 1D array, 2D array. There would be scenarios where you would be working on a 3D array. One of the scenario where you work on 3D array is basically when you do image processing. Image is basically made up of pixels, and each pixel has got three values: R, G, B. So if you convert the entire image as a data set where you replace each pixel by its values of R, G, B, you can visualize it becomes a 3-dimension array. So most of the time you will encounter 3D array in image processing data. So let's get started by creating our first NumPy 1D array. So here, if you see my list, I've created a list, and you will say, okay, my list, but this is not a NumPy object. Please understand, it's not an array, it is a list. Okay. The moment I call numpy.array my list, this list, which is a set of sequential values, will get converted into an array, and that is a one dimension array. Okay. Second example, here I got a set of values, and this is another set of values, and this is a third set of values. So basically a list containing 3 sublists, and each of that has got 3 values. I pass this sublist to an array, and the moment I pass it to an array, it will become a 2D array. The data will get shown something like this. What I'll do is I'll make one of this to character. I have made the first number 1.5. I've enclosed it between double quotes. The moment it gets enclosed in double quote, it will become a character. Now let's see what happens. So if you note here, this one is shown as character and rest of the values are shown as numbers. Reason is a list can contain values of different types. However, when I talk of NumPy 2-dimension array or NumPy array, in a NumPy array, all values have to be of same type. For example, we'll make changes here also. I make the first value as character. This becomes entirely a array, one-dimension array of characters. Okay. The way you can also think of a 2-dimension array, which is shown here at the bottom. Once let me rerun it. This 2-dimension array, the way you can think it as a matrix. In Python, we do not have any object specifically called as matrix. We all know what is a matrix. A matrix is a 2-dimension structure, m cross n, m rows, n columns. That kind of a structure is a matrix. In Python, we do not have any object called as matrix. 2-dimension array is also used as a matrix in Python. Now, where we will find the application of 2-dimension arrays? In machine learning, when we build models, y as a function of say variable x1, x2, x3, something like this, and you have got say hundreds and thousands of records. Okay, y is your output variable, target variable. X1, x2, x3, and you can have xn. You can have many input variables, also called as independent variables. To build a model in machine learning using scikit package, one of the important package in machine learning for model development is scikit. In scikit package, you cannot have any independent variable as categorical variable. What I mean by categorical variable is, say gender. Gender is a variable, categorical, male, female. However, if you have to use that variable, what you will have to create a flag gender or is male. You may have to create some variable saying is male. If the person is male, 1, else 0. So similarly, for all other categorical variables, you will have to convert them into some format of numeric. and any variable which is numeric is by default numeric. Okay, so what will happen is you have converted all variables categorical to numeric, and numeric are already numeric. That structure is actually a matrix, two-dimension matrix, and that two-dimension matrix which you will pass as an input to the machine learning model will have to be a two-dimension array, which is a numpy array. So this is where numpy arrays are very useful. So if you see, this is the ecosystem. So here I will have a pandas data frame which will have columns which can be numeric and categorical. But for using those columns, when I run a machine learning model using scikit-learn, all of those columns will have to be converted into a numpy array format, and that numpy array format can then be passed to a scikit-learn for model development. So this is where a knowledge of numpy array is very essential. So in this example, we are now creating a three-dimension array. It's slightly difficult to visualize and understand. So basically, if you see, this set of three values is actually your third dimension. So what I mean by the third dimension is a structure something like this. So here you got one column, this is your second column, this is your first row, and this is your second row. So the first row and first column is something here, 1 comma 1. First row and second column is somewhere here. Now in this cell there are actually three values sitting, and those three values are actually in the third dimension. So if I can have the values of the third dimension shown here, so basically it has got three values, R1, 2 and 3. So this is how basically actually you've got a three dimensions. So the first dimension is R1, the second dimension is 2, and the third dimension value is 3. So it is slightly difficult to understand this three dimensions. Okay, so what I would do is just execute the syntax. So here you have got R1 comma 2, and the third dimension has got the value 3, which is actually shown like this, a three-dimension format. Okay, you can just imagine RGB. So image, I'll just erase the inks. When you have an image, so there is certain image in this rectangular box. This is a pixel. Now this pixel has got RGB value 3 values, but this pixel is located at what point? So the first dimension x1, x0 will say where is the location of this pixel on the x-axis, on the y, on the row axis. This pixel, where is it located on the second dimension, that is the column dimension. And this pixel is red in color, which has got three values. RGB. Those three values will be stored where? In the behind. Because that, when I say behind, basically in this location there is another list, a list which is actually capturing the three values. Okay, so that's what I'm trying to explain, that there are three dimensions for an image. The X, the row dimension, the column dimension is capturing the location where that pixel is on the overall image, and the third dimension is capturing the RGB information. So for, you can now imagine, for each of the pixels the same thing would happen, and that's where you get a very complex 3D array, and each of this will be a list in list format. I hope I have been able to at least able to communicate the 3D, how 3D information is stored for an image, and based on that you have to visualize a 3-dimension array. Having understood that, I think so this example will not give you more detailed, may not help get that perspective of a 3D array. So if you wish to execute it, execute, but if you have to wish to understand, if you have to understand, imagine it as a image, and then think how 3-dimensional information of a image will get stored. Not data types, attributes, some default attributes. Okay, so a NumPy has got certain attributes. One is shape, second is size, then dimensions, then how much bytes, and data types. So basically the first array that we created, I'll just run this part. So the first array we created 1D. If I say data type, second one D type, data type, third one D type, it says me, okay, the first one is of U2 character because I changed it. Let me make it once again number. Yeah. So now I run this, it will say int, float, and string. Now the second one is shape. If I run this shape, it says that okay, it's 3. There are 3 values, 1 dimension. Then it is 3 by 3. It's basically 2 dimension. Okay, and then 2, 2, 3. So basically, as I created a rectangular box, 2 by 2, and then a third dimension. So basically 2, 2, and 3. Okay, so it's 2 rows, 2 columns, and then in the z-axis, on the z-axis you have got 3 dimensions. So how many dimensions are there? It's a 1-dimension array, 2-dimension array, 3-dimension arrays. And note, when I run this array 1D dot num, I'm not using any bracket. When I have a bracket, the moment there is a bracket, it means it becomes a function. A round bracket coming up, it is a function. But if I do not have any bracket, this bracket is for the print. Okay, this bracket which is in green is for the print. But if I don't have any bracket for a object dot, what I make use in that case is attribute. Okay, that is an attribute. What is the attribute? Attribute is something which defines the object. Okay, for example, if you have to understand the difference between attribute and a function, human face. A human face, what are the attributes of a human face? The attributes of a human face is it has got 2 eyes, 2 nostrils, 1 mouth, 2 ears. Okay, those are attributes. But when I say function, the function of eyes is to see, the function of nose is to smell. So that's a difference between an attribute and a function. With I'm using an analogy to try to explain. Attribute is something which defines what are things present in that object. So here when I say attribute, size, what is the size of the file? Size of the file is an attribute of that. If the size is too large, we will say the file is large in size. Okay, but how large? Okay, it is 140 MB or it is 1 GB. So size is attribute, it is not a function. Okay, so these are certain default attributes. The point is just to make you aware of the point concept. Attributes, certain defining aspect are called attributes. So these are the 5 attributes which are highlighted. Just quickly read through. There's not much to learn in this, but this is just to understand that certain default attributes comes along with the NumPy object. So we can reshape an array. I'm not going to cover this, but I'm just going to keep the screen here so that in case you want to type it. Basically what reshape is saying is I can change the structure of an array. I'm creating here a one-dimension array, and then I'm reshaping it. I'm making it 2 by 4. Or here I'm reshaping it, I'm making it 4 by 2. Okay, here I'm again reshaping it and making it 8 by 1 structure. So basically I can reshape an array. Okay, so similarly you have got something called as resize. Okay, so here the values, there are 1 2 3 4 5 6 7 8, and then I'm saying resize it. Okay, so the moment I resize it, it becomes 4 by 2. So reshape, resize basically are to convert the array from one particular shape to another shape. Okay. So let's just quickly see some important functions. So here I'll just focus on the screen so that for a while, so those who are going to try it out, when they see the video, you can pause it and run the syntax. This is reshape. Okay, yeah, let's move forward. So here what we are now going to learn are some built-in functions which are important for creating arrays. In one of our earlier session we already saw range. Range is basically something which gives you a range of values, start index, end index. NumPy has got a function called a range. A here is for array. So when I call numpy dot arrange, it will return an array. Okay. So when I say np dot arrange 0 to 10, in that case it returns me an array 0 till value 9. Reason 9 and why not 10? Because end index is not inclusive. The same function a range, when I change and I say a range 0 to 11, now this time I've gone till 11, not 10. Start index is 0, end index is 11, and then I give one more parameter value 2. The 2 here is basically steps. In what steps you want the values. So when I start with 0, the first one is 0, then a step of 2, 0 plus 2, 2, then a step of 2, 4, then a step of 2, 6, step of 2, 8, step of 2, 10, and step of 2, 12. But end index is 11. So I reach till 10. In case I would have put this as, 1 minute, let me run it. In case I would have put this as 10, the value would have stopped till 8. Okay, once again 11, control enter. Yeah, so a range is a function which returns a array one dimension using numpy a range function. Now let's come to linspace. Now in linspace, what we are saying is we have got a start number, we have got an end number, and I don't know what is the step, whether it should be step of 2 or whether it should be step of 3 or whether it should be step of 0.4, whether it should be step of 0.6. But what I know is from this start range to end range, I want to break that into 11 values. So if you see, I've given 11. So 0, 0.51, 1.52, 2.5, then 3, 3.5, 4, 9, and 4.5, 5.5. Here we have taken, naturally it has come as steps of 0.5, but if I would have said 0 and 6, and I say you have to break it such that you get evenly spaced 11 values. So we'll have to do some computation, right? But there is a function called linspace. I can do the same thing and get the output using a range, but in that case 0, 6, and what should be the step I'll have to pass here. But in case I don't want to do the computation, I can use linspace. Now in this case, it is determined. If I say I want to break it into 8, so it will naturally determine what should be the difference between the two numbers, do the calculation, and give you the evenly spaced sequence of values in a one dimension array format. So coming back to the original example which I had, this one. So this is where you have got linspace function which you can make use of. Okay, so when you see this a range and linspace function, basically what you're getting is a sequential values. But what if I want random values? I don't want sequential values. I want random numbers. So we have got something called as random number generators in NumPy. So here I have got numpy.random .rand function. So basically numpy is my main package, in that this would be a sub package, and in this sub package this is the function. Okay, when I'm calling the syntax something like this, so basically there is a main package numpy, in that there is a sub package random, and that sub package has got a number of functions, and one of the functions is rand. So now when I run this rand function, it is actually a uniform number generator. What do you mean by a uniform number generator? What it means is give me certain random numbers, and here when you use rand function, the default start index and end index is 0 and 1. So it will return you values between 0 and 1 only, and all these numbers will, now between 0 and number 1 there are infinite numbers, but the probability of any number getting randomly generated is more or less similar. Now what I mean by this is, say between 0 and 1 I want to generate 100 numbers. Just imagine I want to generate 100 numbers. Now if I ask you how many numbers will be between 0 to zero point 0.1, how many numbers will fall between 0 to zero point 0.1, let us do that exercise. I've generated 100 numbers, and in this 100 numbers I'm going to find out all numbers which are between 0 to zero point 0.1. This is 0.6, this one is less than 0.1, so it is between 0 to 0.1. This is one number. Then quickly let's see, I'm checking out numbers. This is second number. This is the third number. This is the fourth number. This is the fifth number. This is sixth number. So I've got 6 values which are between 0 to 0.1. If I increase this 100 to 1000 random numbers, what you will see is as I increase the number of random numbers between 0 to 0.1, because the entire range is 0 to 1. So 0 to 0.1 is 10%. Approximately 10% of the numbers, as you keep increasing the size of the random numbers being generated, you will note that between each segment 0 to 0.1 or 0.05 to 0.15, approximately 10% of the random numbers will fall in that much percentage of the range. Okay, whatever range, if you take 0 to 0.25, out of 0 to 1, that is 25%. And then you see how many numbers are generated in that range. You will find that approximately 25 numbers would be there. Okay, this is the concept of uniform. Basically, in any given range, the choice of the variable, choice of the random number is more or less uniform. So here I'll make it once again 10. Then there is something called as normally distributed. Now, what is normal distribution? We have to first create a diagrammatic view. So let's just make a quick diagram of a normal distribution. This is a normal distribution. So if I have a normal distribution, and again the range in this case will not be between 0 and 1. Okay, because in a normally distributed data, the mean is 0. So when I create a normally distributed data, the average of all the numbers will be equal to, average is represented by a Greek symbol mu. So mu will be equal to 0. And if I compute a standard deviation, these are qualities, these are statistical properties of a normal distribution. The standard deviation will be equal to 1. With regards to that, you will have the random numbers generated. So that is called as normally distributed random number. And the function, if you notice, here it was rand, here there is rand n. N is for normal distribution. Now let me quickly explain the third function. And the third function is Randint. Now I don't want to complicate while I'm explaining. I can run the syntax something like this: numpy dot random dot rand int. Now when I say rand int 1 comma 100, so what I'm saying is give me a random number between 1 to 100. So it will return only one number between 1 to 100. But if I pass one more parameter, say 5, so what I'm saying is give me random numbers between 1 to 100, and how many values I want? 5. Okay, so this is random numbers but integers. Now when do you require these random numbers, integers, or rand function? This one, this and this one. When do you use it? These are used when you want to do sampling of a large data set. So when you want to do a sampling of a large data set, Just visualize you have got a large data set which is in a tabular format, something like this. You've got a tabular format. So what we can do is I want 25% records to be selected from a large data set. Now when I have to select 25% record, typically what you will not do, you will not take that initial 25% of records, because in that case it is not a random selection. So the way you do is typically you create a column random, and using this kind of a function you will create a column random, and in that column you will randomly fill certain values using this random number generator. And then what you will say, any record where the value is less than 0.25, select those records using the filter function that we just learned. Okay, using the filter function, select all of those records by applying a condition random number less than 0.25. And when you select that way, what will happen is approximately very close to 25% records will get selected. Okay, likewise you can use this function where I will generate, say here the number of rows are 1 to say 50,000. So I can generate from 1 till 50,000. Now 1 to 50,000. Okay, I want 25% observation. When I say 25% observations, it means 50,000, 25% will be 12,500. So what I'll pass the third parameter is 12,500, and it will return 12,500 integers. Each data frame has a row number. This integer I will take as a row number, and I'll say whatever are the integer values here, those rows I want to select. I want to select those rows, and this I can use something called as sampling with replacement. These are applications where you will use these kind of things. I can do sampling with replacement, because when I generate a random number using this, there will be certain numbers which will come multiple times. So I have explained the applications where these functions are used. Okay, so now at least because you know the applications, you will understand what is the importance of knowing these kind of functions. With that knowledge, I would suggest that you should run these functions, but before that, okay, so these are the functions that we have, and this is the way where you can have complicated. I've just complicated it from numpy.random import randint function, and import this function. I have renamed it as rint. So this is the way, and I here this is another approach. Okay, so these are all functions for random number generator. Practice them. Just for more clarity, just assume this is like a table. This set of selected data is like a table, right? Now whenever you have a data, this 1 2 3 4 5 6 are row numbers, right?
Yeah.
So when you have these row numbers, I generate random numbers, and those random numbers will come 2 4 8 16 20 5 9 3 6 something. And then what I'll say, okay, all those random numbers, those rows be selected, and that's where you have this function which we'll see later while using how to go about using these functions to select data from a data frame. Okay, but for now, high level just understanding, this is like a data frame. In this data frame, these are the row index numbers. I generate a random set of numbers where this randint function will give certain set of random numbers, and those random numbers I'll then apply a filter function and say whatever numbers are there, those index position rows be selected, and when I select only those index position records, I will have a sample which is randomly created. Let us just take one more example of random integer, whether to see whether these numbers repeat or not. We'll increase the size of number of random integers. So here I made it 50, and let me just quickly see whether there is any number which is repeating. 26 is there, 60 is there, so any number which repeats. 90, 50, yeah, 90. So here you can see this 90, and here there's a 90, and here there's a 90. So by default, when you generate a random numbers between a range, there is a equal probability which you are assigning for any number to be selected. And because there is a equal probability at each time I draw a number from this range, and I have to draw 50 times, but the probability of number being selected each time is equal, so I can have any number coming multiple times. Now let's just quickly see some more functionalities in NumPy. Basically something called as NumPy indexing. Basically here array 1D 0. So basically I'm saying give me the 0th index position value. Then I'm saying array 0 colon 2. So by giving the index positions, I'm retrieving the values. So here, so 0th position is 10 and 0 colon 2 is 10, 20. Then similarly, if I create a 2-dimension array, so we are using a 2D array which was created earlier. So when I say 2D is 0, it gives me the first row. Okay. Then when I say 1 comma 1, so it gets the first row. Okay, this is 0th row. Then this is the first row, and in the first row give me the first index position column value, so that is 5.5. so that's how the indexing is. The recommended way of running the syntax is something like this. Now here when I say 2 comma 0, I'm passing two parameters. So 2 is the second row, this is row position, this is the column position. So I say second row, and in second row 0th index column value, so that is 7.5. So this is a recommended way. Rather than using two rectangular brackets, pass both the parameters separated by comma. Okay, this is how you index and refer values. Then there are more further ways of indexing. When I say colon 2, which means 0 to 2, and when I say 1 colon, it means start from one first index position till whatever is the last index available in the data. Okay, so when I just say colon 2, which means start from the 0th row index position till 2, it is start index is 0, end index is 2. This is the same effect as running like this colon 2 or 0 colon 2 has got the same effect. Okay, so these are certain ways of indexing the elements within a matrix, within a 2D array, and selecting the specific values. Then you can have some conditional selections also. Okay, so here when I'm saying from this array 1D array, I want all values which are greater than 4. So I'm applying a condition. The moment I apply a condition, you can see values which are less than 4, it comes false, false, false. Values which are greater than 4, they come as true, true, true. And now this condition is giving me a list, a array of false and true. Now this array of false and true, I am actually capturing in some parameter, say bool. Okay, this parameter I then pass it to the main one dimension array which I created, and based on the condition only those records are selected. The simple way is I directly put the condition. This is my array name con air, and this part is the condition. And what I'm saying is wherever the condition is met, those index position, the value become 100. So wherever the value is greater than 2, the value should be replaced by 100. Control enter. So this is the output which we get. So what we are trying to show is in this how to go about indexing an numpy array, and based on index I can select the values. In case I want to select the values based on certain condition, okay, you can apply the condition and still select the values. With this, we come to end of our session on NumPy. In our upcoming session, we will discuss pandas. Till then, see you. Bye bye. Thank you.